Many believe meditation is about clearing your mind. In fact, it thickens your cortex. Specifically, the prefrontal cortex, responsible for decision-making, and the anterior cingulate cortex, which governs self-regulation. Harvard researchers found an 8-week meditation program led to increased gray matter density. This isn't mere relaxation, it's a structural change. While stress shrinks the hippocampus, meditation does the opposite. This neuroplasticity isn't just a theory, MRI scans prove it. The changes occur over weeks, not years. Meditation doesn't empty the mind, it rebuilds it neuron by neuron. Each session reshapes synaptic connections, enhancing your brain's resilience against stress. Common belief is meditation lowers stress by reducing cortisol levels. While cortisol does decrease, the real action happens in the amygdala. This emotional processing hub physically shrinks with regular practice. A study from Massachusetts General Hospital showed decreased amygdala size after just 8 weeks. This isn't metaphorical, it's measurable. Shrinking the amygdala means reducing its control over fight or flight responses. Meditation acts as a sculptor, reshaping emotional circuits. This structural change means your brain becomes less reactive to minor stressors. Neural pathways that once accelerated stress responses now shift. The physical shrinkage of your amygdala is a cornerstone of meditation's impact. People often think meditation is about focusing attention. It actually trains your default mode network, the brain's autopilot. This network is active when your mind wanders. Meditation strengthens the connection between this network and the prefrontal cortex, improving attention. Research at Yale University found improved connectivity associated with reduced mind wandering. Meditation reconfigures these networks, enhancing focus even outside meditation sessions. It's not about forcing focus, but about rewiring the brain to naturally sustain it. The changes in connectivity are not abstract, they're visible in fMRI scans. Your brain starts operating differently, not because you force it, but because you've rewired it. While many view meditation as a passive activity, it's a neurological workout. Each session increases brain-derived neurotrophic factor, BDNF, a protein that supports neuron growth. This isn't just chemical, it's a mechanism for synaptic plasticity. A study in 2012 found a 16% increase in BDNF levels after regular meditation practice. This boost enhances learning capacity and memory retention. Meditation turns your brain into a more malleable, adaptive organ. BDNF acts as fertilizer for your neurons, promoting resilience and growth. It's not only about stress relief, it's about constructing a brain that can handle stress more effectively. Meditation alters the chemical environment of your brain. Meditation is often equated with relaxation, but it's more about balance. It recalibrates your autonomic nervous system, shifting from sympathetic to parasympathetic dominance. This physiological shift decreases heart rate and respiration, a measurable effect. Researchers at the University of Wisconsin found that meditation increases vagal tone, a marker of parasympathetic activity. Enhanced vagal tone means improved emotional regulation and resilience. These are not abstract concepts but physiological realities. Your nervous system isn't just calmer, it's recalibrated for efficiency. Meditation creates a tangible shift in autonomic balance, preparing your brain and body to respond to the world with equanimity. Cortisol, the stress hormone, wreaks havoc on your hippocampus. Meditation, however, increases hippocampal dendrite density. Dendrites are the branches of neurons, crucial for signal reception. A study by UCLA showed that experienced meditators had denser hippocampal regions. This density enhances cognitive function and memory. Cortisol shrinks these dendrites, impairing cognition, but meditation counters this shrinkage. This isn't just psychological, it's a cellular transformation. The hippocampus, responsible for memory formation, becomes a more robust structure. Meditation doesn't just soothe, It fortifies your brain's ability to learn and remember. Each session reinforces dendritic architecture, improving resilience against stress-induced damage. Dopamine, the neurotransmitter linked to pleasure, is also modulated by meditation. Chronic stress downregulates dopamine receptors, dulling reward sensitivity. Meditation reverses this process. Research by the University of Montreal found that meditation increases the density of dopamine receptors. This boost enhances your brain's reward system, making everyday activities more satisfying. Meditation refines dopamine signaling pathways, which can alleviate symptoms of depression and anxiety caused by receptor downregulation. This isn't an abstract benefit, it's receptor-level modulation. By increasing receptor density, meditation enhances your response to positive stimuli. The brain's reward circuitry becomes more sensitive, improving mood and motivation. The basal ganglia, crucial for habit formation, are influenced by meditation. This region encodes habitual actions into neural pathways. Meditation interrupts these automatic loops, promoting conscious choice. Researchers at Stanford observed altered basal ganglia activity after meditation training. This interruption helps break negative habits, replacing them with intentional behaviors. Meditation doesn't just relax the mind, it rewires habit loops at the neuronal level. Basal ganglia activity shifts from automaticity to intentionality. It's not about suppressing habits but retraining the brain to choose differently. The neural encoding of habits is recalibrated, offering a path to behavioral change through structural modification. Meditation alters the activity of the default mode network, DMN, responsible for mind wandering. Chronic DMN activation is linked to rumination and anxiety. Meditation decreases DMN activity, observed through fMRI studies at Harvard. This reduction in activity means less mental chatter and greater presence. Meditation creates a brain less prone to wandering, enhancing clarity and focus. The DMN shift is not a side effect but a targeted recalibration of neural circuits. Reducing DMN activity fosters a brain more aligned with present-moment awareness. It's a network-level change that enhances cognitive control, diminishing the frequency of intrusive thoughts and mental noise. Meditation influences brain-derived neurotrophic factor, BDNF, expression, critical for synaptic plasticity. Under stress, BDNF levels drop, impairing learning and memory. Meditation boosts BDNF, observed in a study by the University of Oregon, which found increased levels after consistent practice. This boost enhances neuronal growth and synaptic connections. Meditation turns your brain into a more adaptable organ. BDNF acts at the molecular level, promoting resilience against stress-induced neural damage. It's not just about stress reduction, it's about fostering a brain capable of change. Enhanced BDNF expression leads to a brain better prepared for learning and adaptation, even under stress. Chronic stress versus acute stress profoundly impacts your brain. Chronic stress shrinks the hippocampus, while acute stress can enhance memory in short bursts. Meditation mitigates chronic stress effects, preserving hippocampal volume. A study at the University of Wisconsin showed meditators had larger hippocampi compared to non-meditators. This isn't just about feeling relaxed, it's about structural preservation. Chronic stress leads to cortisol accumulation, damaging neural tissue. Meditation acts as a buffer, reducing cortisol levels and protecting brain structure. The contrast between stress types highlights meditation's role in long-term brain health. This structural preservation defies the typical stress-induced neural decline over time. The self-help industry often claims meditation transforms your mental state instantly. However, neuroscience reveals gradual changes. Brain imaging studies show that consistent practice over weeks, not days, leads to observable changes in brain structure and function. Short-term effects might feel calming, but long-term practice rewires neural circuits. The University of California's research confirms that sustained practice enhances brain regions linked to attention and emotional regulation. The brain doesn't change overnight. It's a process of incremental adaptation. The neuroscience underscores the need for sustained practice, contrasting with quick-fix claims. Real transformation in neural pathways is a gradual cumulative process. Popular psychology often oversimplifies brain changes from meditation, ignoring individual variability. Brain imaging studies reveal diverse responses based on genetic and environmental factors. A study by King's College London found significant variance in meditation-induced changes among individuals. Brain plasticity is influenced by numerous variables, including baseline stress levels and genetic predispositions. Not everyone experiences uniform changes. The brain's response is as unique as its owner. This variability highlights the limits of generic self-help claims. Brain imaging contradicts one-size-fits-all narratives, emphasizing the complex interplay of factors affecting meditation's impact. The brain's adaptive capacity varies, reflecting a personalized journey rather than a uniform transformation. Long-term meditation practice reveals significant neural adaptations in emotional processing. MRI studies indicate reduced amygdala reactivity over years of consistent practice. This isn't about emotional suppression but recalibration. The amygdala's role in processing fear and anxiety becomes less dominant, allowing the prefrontal cortex more control. Long-term meditators exhibit greater connectivity between these regions, enhancing emotional regulation. The shift isn't immediate. It's a gradual rewiring of emotional circuits. The amygdala's reduced influence translates to improved emotional resilience, an effect documented in longitudinal studies. This transformation highlights meditation's long-term role in emotional health, contrasting with short-term stress relief perception. One study stands out, a 2011 Massachusetts General Hospital study that found mindfulness meditation increased cortical thickness in the brain by 0.005 inches over 8 weeks. This might sound small, but it signifies significant neural growth. Cortical thickness is associated with enhanced cognitive functions like memory and decision-making. This isn't about becoming a different person overnight. It's about incremental brain changes. The study reveals meditation's tangible effects on brain structure. Rather than offering advice, it reframes meditation as a tool for neuroplasticity. The number underscores meditation's power in physical brain alteration, defying simplistic self-help narratives with measurable, structural evidence.